In this video, we'll look at an example of a conditional probability situation that has rather counterintuitive features, and it has to do with testing for the HIV virus. There's a test called the EIA test for HIV, and the quality of tests for various conditions is measured in terms of two specifications. One is the sensitivity, which has to do with the percent of people who are infected who test positive for the infection, and the specificity, which has to do with the percent of non-infected people who test negative. And if you look at the values that are given here, you see the sensitivity for this test is 0.997 and the specificity is 0.985, and you think, great, it's pretty much doing the job that it's supposed to do. It's detecting infections most of the time, and it's detecting non-infections most of the time. But because the fraction of the population that has an HIV infection in the U.S. is relatively low, you end up getting some sort of unexpected elements of this situation, and so we're going to explore that a little bit. We're going to start out with a contingency table. People either have an infection or not, they either test positive or not, and of course the total of all the probabilities has got to be 1. It says here that about 0.6% of the U.S. adult population has HIV, so the percent of people infected, or the probability that somebody's infected, if you take somebody at random from the population, is 0.006, which means that the probability somebody is not infected is 0.994. And then we have to try to somehow fill in the body of the test. And the way we get some traction is by noticing that 99.7% of infected people test positive. So we can fill in this cell over here by taking 0.006 times 0.997, and there's a fair amount of calculator button pushing that I'm not going to reproduce on this video. But it turns out that when you do this calculation, you get 0.005982. So that would be the fraction of the population that is both infected and tests positive. We can then subtract that from 0.006 to get the number in this cell, and it is 0.000018. We can now go down here and use the specificity to fill in this cell, because this is going to have to be 98.5 of the 99% of the 99.4% of people who are not infected. And so 0.985 times 0.994 turns out to be 0.97909. We can then add these two, and that's 0.979108. We can do a subtraction here. We get that this is 0.01491, and then we can add these two to get 0.020892, and then if you want to double check yourself, you could add these two numbers and they should go to 1. But now the interesting bit occurs when we actually start making these calculations. So the first thing I'd like us to take a look at is the probability that you're infected given that you test positive, because if a person were to take this test and come back positive, obviously it would be an awfully concerning thing. So what's the likelihood you actually have the disease? Well, or have the infection. So the denominator is going to involve the number of people who test positive, which is 0.020892. That's the given in this conditional probability. And then the number of people out of that group who actually are infected is 0.005982. And if you do the calculation, interestingly enough, you get 0.29. So the probability that somebody who has tested positive actually has an HIV infection is only 0.29. So then what do? Then you maybe go to further testing, or you try to go to maybe a more expensive and more sensitive test and try to refine your situation, really figure out, does this person actually have the infection or not. We can also take a look at the probability that somebody with a negative test is not infected. And so if you have a negative test, that denominator is 0.9799108. And the people out of that group, or the percent of the people out of that group who, the percent of the total within that group who are not infected is 0.97909. And that turns out to be about 0.99998. So this test is very good at detecting who doesn't have an HIV infection. If you test negative, the probability that you're not infected is incredibly high. But paradoxically enough, if you test positive, there's going to need to be some further investigation because the probability is less than a third that you actually have the infection.